Welcome to Spaceverse, your portal to cosmic adventures. Tucked very close to the Sun, a small planet conceals vast mysteries. The tiny, hot planet Mercury tricked us for a long time. Yet recently, space robots have found some strange discoveries. Gems on the sunniest planet, so the story goes. Not to mention that this is only initially. All wrong with Mercury's interior too large and weird. How is Mercury unique compared to other planets, and is there anything else it's trying to hide? From astronomers to space nerds, Mercury, the smallest planet in our solar system, has captivated them all. After decades of concealment, the secrets of its enigmatic terrain finally started to emerge with the advent of modern space travel. The Messenger probe, launched in 2004, resumed the adventure begun in 1973 by NASA's Mariner 10 mission to investigate Mercury's mysterious topography. Thanks to Mariner 10, the first spacecraft to ever visit Mercury, we got our first good look at this enigmatic planet. During its flybys, it took pictures that resembled our moon in that they showed a surface with many craters and peculiar ridges. The mission's findings showed that Mercury had a larger than expected core, a magnetic field that was stronger than anticipated, and an exterior that was both sharp and cratered. This new information cast doubt on the compositional assumptions that scientists had previously made regarding Mercury. After 31 years since Mariner 10, the Messenger mission, also known as the Mercury Surface, Space Environment, Geochemistry, and Ranging Mission, took our knowledge of Mercury to a whole new level. In order to conduct a more thorough investigation of Mercury, Messenger was engineered to enter orbit around the planet, unlike its predecessor. With an astounding 200,000 images, Messenger revealed hitherto unseen regions of Mercury during its mission. The extremely high concentrations of magnesium and calcium found on Mercury's shadow side were one of the most remarkable discoveries made by Messenger. This prompted investigations into the mechanisms that may cause such concentrations. Further surprising relative to other planets, the mission discovered that the northern regions of Mercury had an exceptionally high magnetic field. These findings caused scientists to reevaluate their previous assumptions about Mercury's creation process and interior structure. Most planets, including Earth, generate magnetic fields from liquid iron in their cores. Mercury's unique interior structure, however, leads to different magnetic activity. Its extreme surface conditions are also notable. Daytime temperatures can reach 806 degrees Fahrenheit, 430 degrees Celsius, hot enough to melt lead, while they plummet to minus 292 degrees Fahrenheit, minus 180 degrees Celsius at night due to its minimal exosphere and poor thermal regulation. Recent investigations have revealed some unexpected surface characteristics on Mercury despite these severe conditions. The Messenger spacecraft found pyroclastic deposits from explosive volcanism and other signs of volcanic activity on Mercury in 2012. Long thought to be geologically dead, Mercury's discovery cast doubt on that assumption. The announcement of the presence of aqueous ice in certain polar craters on Mercury by scientists in 2020 was even more intriguing. Water ice can be preserved in these constantly shaded places, even though the planet is so near to the Sun. This discovery has raised fresh concerns regarding the possibility of primitive life on Mercury. Are these frozen havens home to extremophiles, the same kind of organisms that thrive in Earth's harshest environments? The Bepicolombo mission, a collaboration between the ESA and the JAA, departed for Mercury in 2018 and is scheduled to reach the planet in 2025. More precise data regarding the surface of Mercury, its chemical makeup, and its geological past should be forthcoming from this mission. Whether it's the presence of aqueous ice or its very strong magnetic field, Mercury never ceases to amaze. What we're going to get into next, though, will truly surprise you. How is it that a planet so near to the Sun experiences a year that is shorter than its day? A year lasting less time than a day. Typically, when we consider planetary motion, we see them revolving around the Sun once a year and spinning daily on their axis. However, Mercury captivates by defying this pattern. A day is actually shorter than a year on this tiny, sunburned planet. Alright, let's dissect this. A single orbit of Mercury around the Sun takes a mere 88 Earth days to finish. A Mercurian year is significantly shorter than ours due to this fast travel. What makes Mercury so intriguing, though, is that it takes an astounding 176 Earth days for the planet to complete one day's spin on its axis. So, on Mercury, a year is actually half the length of a day. Astonishingly strange outcomes result from this out-of-the-ordinary circumstance. The sun rises and progressively grows larger in the sky as it slowly glides across the skies, as seen from Mercury's surface. The sun would seem to pause, travel in the opposite direction for a short period, and then resume its original course. Because Mercury's spin isn't fast enough to match its orbital velocity, this bizarre dance occurs. So why is Mercury's rotation so sluggish? Tidal locking, according to scientists, is to blame. Because of the sun's gravitational influence, Mercury's rotation has been slowed over billions of years. Mercury, on the other hand, is in a 3-2 spin orbit resonance, which is different from the moon's tidal locking to Earth. This indicates that for every 2 orbits around the sun, it does a full rotation. This peculiar day-night cycle has tremendous impacts on Mercury's surface. The side that faces the sun experiences scorching heat for months on end, while the side that faces the night stays in pitch blackness for just as long. As a result, we see some of the solar system's most dramatic temperature swings. If we're going to talk about the atmosphere, or lack thereof, on Mercury, we should know that the little atmosphere that the planet has is known as an exosphere. Various processes continually renew this extremely thin layer of gases as they are lost to space. Micrometeorite collisions, radioactive decay, and the solar wind all play a role in keeping Mercury's delicate exosphere in place. The exosphere of Mercury has some unexpected components, according to recent observations. Using data collected by the MESSENGER mission in 2020, scientists found that there is more water vapor in Mercury's exosphere than was previously believed. Scientists think that the combination of oxygen in Mercury's surface rocks with hydrogen from the solar wind is what causes this water vapor to form. Mercury's short year and long day affect its magnetic field, which surprised scientists due to the planet's small size and slow rotation. New research suggests that a unique dynamo effect in its liquid metal core generates Mercury's magnetic field, which shields its thin atmosphere from the solar wind. Mercury's fast orbit and slow rotation create hot poles, where the sun seems to freeze in the sky, leading to extreme heat. Meanwhile, areas near the poles remain permanently shaded and cold, where scientists have found evidence of water ice. This unique combination of orbit and rotation raises the question, can these cold traps also preserve other volatile compounds? Studying Mercury is challenging due to its short year and long day. Its rapid orbit makes it hard for spacecraft to reach. They must perform complex maneuvers, including multiple flybys, to slow down enough to enter Mercury's orbit. The Bepi-Colombo mission, launched in 2018, will reach Mercury in 2025 after 9 planetary flybys. Once in orbit, Bepi-Colombo must manage extreme temperature fluctuations between Mercury's hot dayside and cold nights, a challenge compounded by the planet's unique rotation in orbit. Recent models suggest Mercury once rotated faster but was slowed by the sun's gravity and impacts from asteroids and comets. This research not only illuminates Mercury's history, but also offers insights into the evolutionary paths of other planets in our solar system. New questions come up as we keep studying Mercury. In spite of the harsh temperatures and lengthy nights, how can the planet's interior continue to be partially liquid? Can we infer anything about Mercury's geology from the planet's peculiar orbit? These inquiries highlight the fact that many unanswered questions persist even within our own solar system. Mercury's peculiarities force us to reevaluate existing assumptions about planetary formation and evolution, and open our minds to new avenues of inquiry. Can you think of any other wild mysteries that Mercury's cratered surface could be concealing? A little planet hiding too many dangerous mysteries. Mercury may be the tiniest planet in our solar system, but don't let its diminutive stature fool you. Mercury, a small planet, continues to confound astronomers with its peculiarities and mysteries. The remarkable size of Mercury's core is one of the planet's most mysterious features. Approximately 85% of Mercury's volume is comprised of its core, according to research spearheaded by planetary scientist Dr. Nancy Chabot of the Johns Hopkins Applied Physics Laboratory. The core of our planet occupies just around 15% of its total volume, so this is a huge deal. Why, though, does Mercury have a core that is so enormous? At one point in the early solar system's history, a tremendous collision may have stripped Mercury of most of its outer layers, leading one hypothesis to propose that Mercury was once a far larger planet. The hit-and-run scenario was created by Dr. Eric Osfog of the University of Arizona. This idea proposes that Mercury's iron-rich core could have formed when a massive planetesimal impacted the planet, removing most of its mantle and crust. Mercury also has an unexpected magnetic field, which is another intense secret. In contrast to Mars and Venus, which do not possess any global magnetic fields, Mercury produces a field that is approximately 1% as powerful as Earth's. Since scientists weren't expecting a tiny planet with a slow rotation to have a magnetic dynamo, NASA's MESSENGER mission was perplexed by this finding. At the helm of an even more startling discovery concerning Mercury's magnetic field was Dr. Katherine Johnson of the University of British Columbia's Planetary Science Department. Their discovery revealed that the field is around 20% of Mercury's radius away from the planet's center. Variations in the thickness of Mercury's crust, which impacts the passage of heat from the planet's interior, could be the cause of this discrepancy. However, the enigmas persist beyond that point. The presence of sulfur, potassium, and sodium volatile elements on Mercury's surface was announced by scientists in 2020. Strangely, these elements were found on a planet so near to the Sun, considering how rapidly they evaporate at high temperatures. Comets or asteroids may have brought these volatile elements to Mercury after the planet formed, according to Dr. Patrick Poplawski of the Johns Hopkins Applied Physics Laboratory. Among Mercury's most thrilling new findings is the existence of water ice in craters that are continuously shaded close to the planet's poles. We also spoke about Dr. Nancy Chabot earlier. She was a part of this study. Since these craters never get direct sunlight, they maintain extremely low temperatures, which is why the ice persists even though Mercury is very close to the Sun. The important part, though, is that these craters have been shown to contain chemical substances as well as water ice. The so-called dark deposits may actually contain sophisticated carbon-based compounds that were around when life on Earth first began. Despite its hostile environment, may the planet Mercury provide information on the origins of life in our solar system? Surprising geological activity on Mercury is another intense mystery. Mercury was considered a dead world by geologists for a long time. Nonetheless, MESSENGER data showed that volcanic activity occurred quite recently. British scientist Dr. David Rothery of the Open University has found what seem to be volcanic vents on Mercury in the form of tiny bright dots on the planet's surface. These so-called hollows provide more evidence that Mercury may be experiencing ongoing geological activity. The chaotic terrain, a large region of unorganized hills and valleys close to Mercury's southern pole, is one of the most perplexing aspects of the planet. This area, which was initially detected by the Mariner 10 mission in the 1970s, encompasses an area about equal to the size of Texas. According to Smithsonian Institution researcher Dr. Thomas Waters, this landscape may have developed as a result of enormous earthquakes triggered by the Sun's tidal forces throughout Mercury's orbital evolution. Surprising insights regarding Mercury's composition have also been uncovered in recent investigations. The University of Zurich's Dr. Amir Khan examined Mercury's interior structure using MESSENGER mission data. Mercury, like Earth, probably has a solid core and a liquid outer layer, according to his team's findings. Mercury may have some unusual magnetic characteristics due to its inner core being proportionately much bigger than Earth's. Our knowledge of how planets develop and evolve is called into question by these profound mysteries of Mercury. They show us that there are many unanswered questions even in our own cosmic backyard. We can't help but wonder, as we eagerly await future expeditions and discoveries, what other surprises could lie beneath Mercury's cratered surface. Unveiling the margins of Mercury. The subsurface of Mercury is hiding secrets that are as intriguing as its surface features, according to recent discoveries and continuing expeditions. Its central structure is one of the most intriguing features of Mercury's deep interior. Mercury has an unusually liquid core with a solid inner part, in contrast to Earth's solid outer core and liquid inner core. The MESSENGER mission, which mapped Mercury's interior using minute changes in the planet's gravitational field, verified this peculiar core composition. Approximately 1,260 miles, or 2,000 kilometers, broad, the solid inner core of Mercury constitutes nearly half of the planet's total core. Compared to Earth's inner core, which comprises just around 20% of the planet's core volume, this is far larger. Although Mercury's magnetic field is significantly weaker than Earth's, it is surprisingly strong for a planet of its size, and this is due in large part to the size and condition of the planet's core. a thinner mantle than previously believed exists beneath Mercury's surface. In contrast to Earth's mantle, which is approximately 1,800 miles, 2,900 kilometers deep, new research suggests that Mercury's mantle might only be approximately 260 miles, 420 kilometers, thick. What this thin mantle means for Mercury's geology and heat distribution is unclear. When MESSENGER found signs of ancient volcanic activity on Mercury in 2012, it was one of the most thrilling findings regarding the planet's interior. Unusual hollows, or shallow depressions, were discovered by the spacecraft. They appear to have formed as a result of volatile materials sublimating from the surface. According to experts, these cavities indicate that there were more volatile materials in Mercury's interior in the past. Another groundbreaking finding on Mercury's subsurface was made in 2020 by researchers utilizing data from MESSENGER. They discovered artifacts that pointed to the existence of a massive magma reservoir on Mercury in the planet's long history. The surface and interior structure of Mercury were probably significantly influenced by this ancient ocean of magma. Some of Mercury's distinctive surface features, such as the expansive, flat plains that span most of the northern hemisphere, may be explained by the existence of this old lava ocean. The northern volcanic plains, as these plains are more commonly called, were presumably formed during Mercury's early past by huge lava flows. On the other hand, 2022 may have seen the most shocking finding regarding Mercury's interior. Nitrogen buried beneath Mercury's surface was discovered by researchers examining MESSENGER data. The enormous heat and solar radiation that bombarded the planet drove this nitrogen underground, leaving behind the remnants of an old atmosphere. Curious inquiries into Mercury's history are prompted by the discovery of underground nitrogen. Is it possible that Earth had a thicker atmosphere in the past? Does this mean anything about its early climate and whether or not it could have been habitable? Water ice in permanently shadowed craters near Mercury's poles is a key feature of the planet's hidden depths. Though on the surface, the ice is nearly invisible due to the extreme cold. Recent studies suggest some of this ice could be relatively young, deposited by comets or asteroids in recent millennia. Dark deposits in these craters might also contain organic molecules, possibly from similar impacts. This offers a rare opportunity to study organic compounds in the inner solar system. Mercury's subsurface shows signs of past tectonic activity. Unlike Earth, Mercury lacks plate tectonics but has significant thrust faults from cooling and contraction. These faults, some reaching several kilometers high, provide insights into Mercury's geology. Recent research indicates Mercury may still experience tectonic activity, with young grabens, small valleys formed by crustal extension, suggesting ongoing crustal movement. The complex nature of Mercury's magnetic field is one of the greatest mysteries surrounding the planet's interior. The magnetic field on Mercury is believed to be created by a different mechanism than the one that causes the field on Earth, the migration of molten iron in the outer core. Some researchers have speculated that it could be created via a dynamo effect in a solid core encased in a thin layer of liquid metal. Subsurface faults on Mercury might allow heat and possibly liquid to move through its crust. Although Mercury's surface is currently dry, some experts believe there could be pockets of liquid water deep underground, kept warm by the planet's core. While underground water on Mercury seems unlikely, similar conditions have been observed on other planets. For instance, Jupiter's moon Europa and Saturn's moon Enceladus both have subsurface oceans. Thus, while Mercury's atmosphere differs, subsurface water isn't entirely implausible. We keep finding fresh mysteries as we delve deeper below Mercury's surface. How has the inner workings of Mercury changed through the years? Are there any other substances or elements that could be trapped beneath its surface that could be volatile? What could the inner planet formation processes and the early solar system's history tell us about Mercury's subsurface? This is the most fascinating question. The significance of ongoing Mercury exploration is underscored by these inquiries. The more we learn about its inner workings, the more we learn about this intriguing planet and how the planets in our solar system formed and evolved. Even though Mercury is small and close to the Sun, there are still many mysteries that need to be solved. This much is certain as we anticipate future expeditions and discoveries on the planet. Its history and maybe the solar systems as a whole may be revealed in its depths. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.